Okay, this is a lesson on section 1.3, combining transformations. And we remember that we have the equation of the transformation, y equals AF of B x minus h plus k. So just starting with a reminder of what each of these things are. So looking at A first, we remember that A is our vertical stretch factor. And when A is less than 0, when A is negative, we have a reflection about the x-axis. B, looking at B, we have a horizontal stretch. But here, the factor is 1 over b, factor of 1 over b, the reciprocal of b. So that's sort of the trick to remember with b. If b is less than 0, then that means we have a reflection about the y-axis. And now lastly, h, this is our horizontal translation. Remember here, watch signs. And k is the vertical translation. So let's look at some examples of equations of transformations and see if we can determine what each number in there means and what effect it will have on the graph, as well as give the mapping notation for each one. So we start off with something simple, y equals 2 f of x. So hopefully you see that a is 2, and that means we have a vertical stretch factor of 2. My mapping notation, xy, becomes x comma 2y. In the next one, a is negative 3. So when we have a negative value, then there will be two things to consider. Firstly, a vertical stretch factor of 3. And secondly, because a is less than 0, that tells me there will be a reflection in the x-axis. In parts C and D, I'm looking at, so here and here, I'm looking at the value of B. So in the first one, B is 2. So that tells me that there will be a horizontal stretch by a factor of 1/2. So here remember, B is not the factor, 1 over B is the factor. And so in my mapping notation, I have xy, and it's going to become 1/2 x, y. And in exercise D, you can see that B is 1/2. So again, that's a horizontal stretch by a factor now of 1 over 1/2, or 2. So I'm going to have xy become 2xy. And so those are fairly easy. Should remember that stuff from previous lessons. And if we look over here at F, I think exercise E got cut off. Maybe it's on the next screen. So anyways, we'll look over here at exercise F. And what the first thing that I want to do before I look at labeling what B and, in this case, H are, is I always have to remember to factor out B. So I'm going to rewrite this as F2, and then 2x minus 4 would give me what I had originally up here. So that means that in this case, B is 2, and h is actually 4. So that's really important to remember to factor out b. And you're going to see that down here in exercise H as well, and then also down here in I. So if b is 2, we have a horizontal stretch, factor of 1 over 2. And we have a horizontal translation 4 units to the right. That's what an h of 4 means. So our mapping notation is that xy will become 1/2 x. We multiply by the factor, remember, not by b, and add 4, and y will just be y. Looking at exercise G, I've got an a value of 3, so that tells me vertical stretch, factor of 3. And I have an h value of -4. Remember, the sign that I see up here is opposite, because this is really x minus -4. So that's why it looks like +4. So that is going to be a horizontal translation, 4 units to the left. So I'm going to put those pieces of information together. My x is going to be affected by h, and the y by the a value. So I would have x minus 4 and 3y. So this would be a good point to maybe pause and try exercises H and I on your own. All right, so let's have a look. Hopefully you got these. Remember here, hopefully you remembered to take out b. So I should have 2 and then x plus 1 and then plus 5 out here. So I have a b value of 2 and I have an h of -1 and a k of 5. So in my mapping notation, I multiply x by the factor. So remember, this b is a horizontal stretch. Factor is 1 over 2. So I'm going to have 1 over 2 times x. And this is a horizontal translation, 1 unit to the left, so -1. And k of 5 is a vertical translation, 5 units up. So this is going to be y plus 5. All right. And the last one, y is f of, and then here again I have to factor out that 1/2, and this one's a little bit tricky because I would think some of you probably put 3/2 right here, but remember that if I times 1/2 by 6, I would get that 3 back. So this is actually 6 plus 4. So I've got a b, I've got an h, and I've got a k, just like the previous one. They're just different numbers. So b is 1/2. That is my horizontal stretch, factor of 2. H is -6, so that's a horizontal translation, 6 units to the left. And k is 4, so that is a vertical translation, 4 up. So my mapping notation is that my original points on f of x now become 2 times x minus 6, which is my h value, comma, y plus 4. So hopefully you got that one as well. This is where our points end up on the transformation. So on the next page, there are 2 more here to do. One, exercise E is written as the equation of a transformation. That's quite easy. And then here, what happened to this if it looks like that? So again, here, please remember to factor out the value of b, and you can try that on your own. The answers are on D2L. Let's look at something different, though. We've seen a lot of those kind of problems. So in this one, we have the graph of f of x over here in blue. So this graph is y equals f of x. And maybe you recognize it as the square root of x. And we're going to sketch the transformation of the f of 2x minus 4. So before I even start, I would probably factor out b. We've been doing a lot of that, so maybe you saw that right away. And I would just point out that b is 2 and h is also 2. So these b and h are both going to affect x. So remember, we have x and y becoming x over b plus h, comma, ay plus k. And that's our mapping notation in general. So in this one, I would have xy becoming x over 2 plus 2, comma, y. And y would then be staying the same. So what I might start doing when I'm thinking about sketching a transformation is think about where are the points on this original graph. So I have 1 at 0, 0. So I'll put that into a table, and this is the f of x, in other words, the original. And then I have 1 right there at 1, 1. And I have 4, 2. The square root of 4 is 2, right? And then you can see out here 9 and 3. Square root of 9 is 3. So there we go. So what I might do now is think about where did those points end up? Well, to do that, I'm going to use the mapping notation that I came up with from the equation of the transformation. So in f of 2x minus 4, I'm going to make another table of values. Might as well make it straight up and down. I don't know why I did that. There we go. What do we got? X and y. It looks like the y's are staying the same. They are 0, 1, 2, 3. So I might just pop those in there because they're not changing, right? Y is still y. But x is going to become x over 2 plus 2. So the first value is 0. So I might just pop that in there. Go 0 divided by 2 plus 2. Well, that's 2. So there's my first point, 2, comma 0. I might plot that. Next one, 1 over 2 plus 2. Again, if you're not sure what I'm doing, I'm putting in these values of x into my mapping notation to then get the coordinate. So 2 plus a half is 2.5. So 2.5, comma 1, that's about there. Next one, 4 over 2 plus 2. That one actually stays 4. 2 plus 2, that's 4. So that point's common. And the last one, 9 over 2 is 4.5 plus 2 is 6.5. So 6.5, comma 3 is about there. And so now I'm just going to connect these with my line, and that's kind of what my sketch looks like for that guy. All right. Now, very similar task. In this bit here, I might just erase this to give myself some more space. Y equals 4f of 1/2 x plus 6 plus 3. And then we just want to say, what does each thing do here? So this is very similar to what we were doing before. Y is 4, oops, and then f of, take out that value of b, half of 12 is going to give me that 6 back that I want, plus 3 out there, close the brackets. So a is 4, b is a half, h is minus 12, and k is 3. And so we could state what each of these things means. Vertical stretch, factor of 4. At this point, you should be kind of pros at this. Horizontal stretch, factor of 2. Horizontal translation, 12 units to the left. That's a negative 12 there. And a vertical translation for last one of 3 units up. Okay, so here's another one. It's a little bit tricky. This is written backwards, right? So you might want to swap that around. You might want to pop that -1 over to this side. There's your k value, and figure that guy out. Answers to this can be found on D2L, so I'll let you guys maybe try that one and just move on to the next thing that I want to show you. Okay, so we are looking at this problem. The graph of the function g of x represents a transformation of the graph of y equals f of x. Determine the equation of g of x in this format, the equation of the transformation. So f of x is our original. And so in this case, we're looking at the graph of the original right here, f of x, which is this sort of smaller version right here. And it's become g of x down here. There's g of x. So whenever we're trying to figure out the equation of the transformation, we want to look at reflections and stretches first. So that's my first step. I want to think about what's happened here in terms of reflections and stretches. So if I look at f of x, hopefully you can see that it's been reflected from being above the x-axis to below it. So that would be my first point. There's been a reflection in the x-axis. And then I would ask myself, what does that mean if there's been a reflection in the x-axis? Well, that tells me that a is less than 0. A is a negative number. And then what I would do now to think about the stretches is I would compare, say, maybe this depth from, where these 2 points are, the depth to that point is 4 units. So I've gone 1, 2, 3, 4, right? And then down here, the depth between those 2 points is still 4 units. So there has not been a vertical stretch. So no vertical stretch tells me that A is just -1. No vertical stretch. And next, I'm going to look at the horizontal stretch. And so again, so remember, this is 2, so this is actually at 1, and this is at -2. So the distance between these 2 points is 3 units across there. And then if I look at where those points ended up, they're actually quite a distance apart, from -7 to +8, and that's 15 units. So in terms of the stretches, there's no vertical stretch, but look at that. 3 became 15. So that tells me there's a horizontal stretch. By a factor of 5. And so remember, with B, it's 1 over that factor. So I know that B is 1/5. And now that I know A and B, I'm going to see, I'm going to calculate rather the value of H and K using the coordinates of some points. So I'm just going to clear this off so we have some more space to work with. There we go. And look at, say, this point right here, which is -2, 0. And it has become -7, 0. So I'm going to use that to calculate H. So remember, in our mapping notation in general, xy becomes x over b plus h, comma, ay plus k. So I've got my original point is this one, which is the -2, 0, and it has become -7, 0. So what I'm going to do is take that original point of -2 the x value, and I'm going to times it by the factor, right? This is like dividing it by 1/5 if you want, divide by b. What that really means is I'm timesing it by 5, right? The factor is 5. So here I'm timesing it by that, plus h has to equal the new x value of -7. So neg 10 plus whatever h is got me to -7. I add 10 to each side, and I can see that h is 3. So there I have calculated the value of h using mapping notation and a point on the original, which was f of x, and seeing where did that point end up on the transformation. And I calculate h using that technique. Now, I picked a different point to find k. We can use the same point, it's fine, but I picked a different one. So I used this point up here, 0, 4 is my original. And that point became 3, neg 4, which is down here. So after the reflection and the stretch ended up at 3, neg 4. So when I'm looking at the y values, 4 became neg 4. And so I'm going to do this process here, ay plus k. So a I know is -1. I calculated that earlier. That was this up here, if you remember, times my y value plus k is -4. This, the new image point over there. So -4 plus k is -4, and you can see right away that k is 0. So at this point, I'm able to write the equation of the transformation. I have all 4 pieces of information that I need. So I'm going to write all those things in their spot. So my equation of the transformation is y equals a, which is -1, f of bx, so b is 1/5. We found that out from our stretch, which was a factor of 5. So b is 1/5. X minus h, close the brackets, plus k, well, that's just 0, so I won't even bother writing that. And this is the equation of the transformation based on a graph. So this is a little bit more work than the other problems that we looked at. There you go.